जिक्र
Welcome on Virtual Lab NWPVL 2024 on the sixth day of this workshop organizing by Government Degree College Badaयूं in collaboration with IIT Kanpur and PSIT Kanpur. There are several participants from different states of the country. We have registered 662 participants from different states of the country for this workshop for semester 1, semester 3 and semester 5. All the three separated workshop for 2 days each semester has been organized, and several students are benefited with this workshop. So on this occasion of the final day of this workshop, we will organize the valedictory session. समापन समारोह आयोजित किया जाएगा at near about 12 p.m. So it is expected to keep your presence in the valedictory session, as Dr. Vinay Tripathi, Project Associate from IIT Kanpur, will be our chief guest. Professor Divangar Sapate from Government PG College, Thane, Maharashtra, and Professor Dr. Bandita Srivastav from KL DAV College, Roorkee, and our principal Dr. Shraddha Gupta will address this workshop, and I will conclude the all the aspects of this workshop. So I would like to request all the participants and all the faculty members to keep their presence on their account anyhow till the workshop will organize finally. मैं राजकीय महाविद्यालय बदायूं के समस्त छात्र छात्राओं से अपेक्षा रखता हूं कि वे अपने सभी इष्ट मित्रों को तत्काल वर्कशॉप से जोड़ें, क्योंकि ये कार्यक्रम आपके महाविद्यालय के भौतिक विज्ञान विभाग द्वारा लगातार 6 दिन से आयोजित किया जा रहा है, जिससे न केवल आपको लाभ हुआ है, बल्कि महात्मा ज्योतिबा फुले रोहिलखंड विश्वविद्यालय बरेली द्वारा जारी राष्ट्रीय शिक्षा नीति 2020 के नवीन पाठ्यक्रम वर्चुअल लैब का जो पाठ्यक्रम प्रेस्क्राइब किया गया है यूनिवर्सिटी के द्वारा, उससे देश के विभिन्न राज्यों के विभिन्न शिक्षण संस्थाओं के छात्र छात्रा भी लाभान्वित हुए हैं। ये राजकीय महाविद्यालय के भौतिक विज्ञान विभाग के लिए बड़े गर्व का अवसर है, और हम सभी की सहभागिता यहाँ प्रतिभागियों के रूप में उपस्थित विभिन्न राज्यों के वे सभी प्रतिभागियों के लिए भी और हमारे विभिन्न शिक्षण संस्थानों के प्राध्यापक बंधुओं के लिए भी हम सभी की जिम्मेवारी है और वर्कशॉप को अच्छी तरीके से कंडक्ट करना हम सभी का दायित्व भी रहा है। इसलिए आज वैलेंटरी सेशन के मौके पर हम सभी अपनी उपस्थिति बनाए रखें और कार्यक्रम को सफल बनाएं। तो हमारी स्पीकर डॉक्टर अपर्णा दीक्षित मैडम, जो पीएसआईटी कानपुर की एसोसिएट प्रोफेसर भी हैं, आप शीघ्र ही हमारे बीच आकर आज का व्याख्यान देंगी और लगभग 12 बजे समापन समारोह की बेला पर आप आईआईटी कानपुर तथा विभिन्न शिक्षण संस्थानों के पधारे हुए शिक्षक विदों से आप लाभान्वित होंगे।
Thank you, sir,
मैडम से
for
अनुरोध करूंगा कि आज का
such a nice
व्याख्यान प्रारंभ करें।
introduction. Yes, sir. Can you see my screen? Okay, beta. Thank you, Sanskar. So again, we'll try to complete. We will try to discuss about at least 2 experiment today. Okay, so that you can have a rough idea, and then once you go back and then try to perform the experiment also. Okay. So today I will try to talk about 2 experiment. That is, one of the experiment is on Newton's ring, through which actually we will measure the refractive index of a liquid. Okay, so this is in the laser optics virtual lab. Now you can see different experiments. And yesterday we have completed Newton's ring wavelength of light, and today we will go to see the Newton's ring refractive index of a liquid. देखिए आगे क्या होता है. Okay, so as I have already said, in every experiment you can see in your lab manual theory, procedure, like observation table. Okay, theory, procedure, aim, theory, procedure, or observation table, then calculation, then percentage error, graphical analysis, then percentage error, and then precautions you usually write. Okay, so here actually we are providing this platform theory, then procedure, and then pre-test in the form of self-evaluation, simulator that is a part of observation table, assignment which is the part of post-test, and references through which actually you some websites there you can have an idea about extra learning. You can basically learn things with the help of references. Okay, so these are some important aspects of as you know, David Holiday actually is the basic regular fundamentals of physics. So I just want to recommend each and everyone, like, please go through this book and read out these chapters 33 to 37. This is a quite very useful book. So when you go these uh, basically links, so then you can have also idea about that. Okay, so here actually in wedge shaped thin film. So first of all, just to determine the wavelength refractive index of a liquid, which is introduced in between the upper surface of the film and lower surface of the film. So basically, the diameter of the ring will get affected. How it is affected, you can see The diameter square is directly proportional to what quantities? Order of ring, wavelength of light source used, radius of curvature, and inversely proportional to the refractive index of a liquid introduced. Okay. So as you can change the source of light, but during observation you are not allowed to do so. So basically, an entire experiment or observation set of observation, you are not allowed to test the source of light, and even of course radius of curvature would be also same. So, but in case of liquid, actually we can pour different type of liquids in between the convex lens and plain glass plate. pour करना मतलब हम उसमें डाल सकते हैं, ठीक. सो नाउ एक्चुअली वी आर यूजिंग, हम यूज करते हैं क्या, we are using Newton's ring assembly. Okay, so in assembly actually it's very difficult to put the entire setup in into the vessel. So usually PSIT we just pour some drop of liquid, right, with the help of drop. So you see some drop of water whose refractive index is 4 by 3 will spread over there. A film will be formed between upper surface of the film as well as the lower surface of the film. Then you can see the dependency on diameter with the refractive index of a liquid. So now you can see there is an inverse relation in between them. So mu increases, of course, it is roughly estimated one for air medium. Air the ठीक है. अब इसके बाद हमें क्या करना है, देन वी कैन सी द डायमीटर स्क्वायर. डायमीटर बेसिकली increases when mu decreases, diameter decreases when mu increases. Both the things possible just because of inverse relation. So when you go through the theory, so you can have this. So this dm plus p square minus dm square is actually this difference in diameter square is measured in case of air film. So first of all, we will perform the entire experiment with air film. Okay, and then what we can do, we will basically pour some liquid drops into the wedge shaped thin film, or we can put this assembly of plano convex lens and plain glass plates into a vessel and then pour the drop of liquid. This liquid may be oil, maybe kerosene type oil, turpentine oil, or you can see some glycerin, right? Or some water also, some, even you can put some alcohol, and then you can see the basically the of refractive index on diameter. So this is the method actually. So we have already done the various light source use their diameter square. So we will write the same value here. Okay. Now if we go with the procedure you can see uh, when we do some experimental arrangement, glass plate is inclined at 45. Why it is 45-degree inclined? So that the incidence become plane and parallel. Plane and parallel. So when you pour some liquid drops of any given liquid in between the glass plate and the plano convex lens, you can see when the light rays comes source normally on the convex surface of the plano convex lens. So light generally reflects from their upper surface, and then when light goes through the film due to change of medium get refracted, and after refraction when it comes to the lower surface, so basically when it comes to the lower surface, here you can see when the light comes from here, light first of all will reflect from here from the surface, but here liquid is poured, so due to change of medium, again this medium will behave like a denser, so light rays will suffer refraction due to change of medium. Again, at lower surface, you can see no change in medium. So basically, at upper surface reflection again occurs, and when the reflection occurs here, so both beam of light, reflected light, will interfere to each other, and due to interference of light, we can see the alternate arrangement of bright and dark fringes where at the microscopic view, at the microscope view. Fine. So this was actually the method to find out the we can say interference pattern by dividing amplitude into two equal halves. मतलब suppose we have a amplitude A incident at normally on the upper surface of the film. So basically it will be divided into two equal halves. One suffers reflection and goes from upper surface, others suffer reflection from lower surface, and then again a by 2 after merging through the lens and glass plate will merge together, and after superposition you can see the result interference of light. So this is the basic concept of we can say interference of light in case of Newton's ring, है ना? अब उसके बाद हम क्या करते हैं choose the number of ring by placing the cross wire at the boundaries of dark ring of second order, fourth order, sixth order, and up to the 18th order. Okay, and then we just find out the diameter square, and diameter square once you have, then take a difference between them successive, and the experiment will be repeated. Okay, so now we are going to perform the in a virtual lab. The simulation virtualizes the Newton's ring experiment. Here we can see the medium change. When the medium changes, so diffraction pattern in the form of Newton's ring basically get compressed because of the inverse relation between diameter square of the ring as well refractive index of a given liquid. ठीक है, उनके बीच में क्या है, इनवर्स रिलेशन है. तो अगर हम वेवलेंथ को रिफ्रैक्टिव इंडेक्स को घटाते हैं तो डायमीटर स्क्वायर इंक्रीज करेगा. इफ इट रिड्यूसेस, इफ इट इंक्रीजेस getting more than one value, so diameter square will reduce. Okay, here actually what we do use as a component start button, light source, filter, microscope, lens, medium, and glass plate. Okay. Now you can see the variable region. Choose a medium combo box. Helps you choose what. Just wait a minute. Let me open my camera first so that I can give you a better idea. Okay. If it works, then it's okay. Otherwise, we'll see the. Okay. So basically, what we are doing here, we are choosing medium combo box just to filter out the mediums, maybe air or some liquid, right? So, whose refractive index is greater than 1. Or even we can put some crunches of glass also if it is in powdered form. Okay, so we can see the effect of diameter of ring on the refractive index. Now we will go to the radius slider, which helps to change the radius of curvature. Okay, the wavelength slider helps to change the wavelength of light used. फिर wavelength slider पे हम करेंगे, so ये क्या करेगा, wavelength को change कर देगा. And go start button will help to play the simulation. When we push on the start button, then क्या हो जाएगा, play simulation. Now we can go through the simulation process. Variation in the ring can be seen when the medium, wavelength of light, radius of. अब क्या क्या चीजें चेंज करना है. वेरिएशन इन द रिंग कैन बी सीन. एक तो मीडियम म्यू हो गया, वेवलेंथ हो गया, रेडियस ऑफ कर्वेचर. दैट इज your value, this D is dependent on directly proportional to the order of ring, and we can say uh, wavelength of light source used, and radius of curvature, and inverse relation between diameter square as well the refractive index of light. Fine. So now we are going to choose the next one step. This is the simulator. Okay, this is the process. We have to just click on these three lines, choose the medium. The entire experiment will be done with the help of air first, and then what we have already done, that same process will be followed here. Same process हमें यहाँ पर भी करना है. Suppose we choose water. Water का refractive index सभी को पता है. It's 4/33. ठीक है. So now you can choose the different light source. As here why no light source is affecting your eye, so no need to afraid about that. But initially we can choose sodium, so let's choose sodium. Okay, now we will keep on the light on हो गया. Fine. Now you can see the better view of the rings. So now let's focus it more. Now it's going fainted. This is quite bad, I think. This is quite better. Fine. I think now rings are configured properly. Is it so or not? Okay. So now we can choose curvature. Suppose we are choosing 60 centimeter. Okay. 60 centimeter microscopic focus, everything is basically set. You can see the result here 5890 angstrom. But the thing is, we have to do process of like we have already used this. Huh? Okay, fine. Now you can move on. Again, we need to make our observation table because in this assignment they do not provide actually observation table actually measurement of refractive index of a liquid. So what we can do separately, no issues. So first of all, we will perform the experiment while and then introduce a liquid. So we and so far now we will keep crosswire bright and dark. Let us choose that. So basically, this is you can see this is the central spot, as this is the case of reflected light because light is coming here, and then you can see the light here. That means follows the laws of reflection. So we can say, okay, no one is going to measure the entire experiment with the transmitted light because in case of transmitted light, due to multiple reflection, most of the light is absorbed by the lower and upper surface of the film. So we can see only fainter spots of bright and dark fringes, nothing else. So better is to view only reflected light. Okay. So now if we go through with the reflected light case, so in this situation, everybody knows the part difference is 2 mu t in wedge shaped thin film, and in reflected light again, first reflection occurs at the rarer interface. So the effective part difference would be 2 mu t plus lambda by 2. Fine. If it is 2 mu t plus lambda by 2, so basically, then you will construct the condition for maximum intensity and then minimum intensity. Then you convert thickness into diameter, and we have the formula. Okay. So here, when we keep this cross wire, you can see this cross wire zeroth order dark ring central spot which is dark in case of reflected light. So we can keep this crosswire at the boundary of dark. Fine. On this side, left hand side as well as the right hand side. So we can do this the sliding the crossfire. This is the boundary of first, and this is the boundary of second dark. Fine. This is boundary of first dark, then second dark. Fine. Okay. Then again, you need to find out the main scale reading and vernier scale reading. This is 3, 2.9, 2.8, 2.765, 4, 2.35 actually completed. So main scale reading is 2.35 and go to the vernier. In vernier, you can see which division is coinciding exactly. Can you see the screen? Can you see the screen? बेटा कैन यू प्लीज टेल मी कौन सा डिवीजन मैच कर रहा है एग्जैक्टली लेट मी enlarge it. Can you see my screen?
Yes, well,
आपको में दिखाई दे रहा है ना? तो आपको ये देखना है कि कौन सा डिवीजन मैच कर रहा है. ठीक है 0 से 10
3.7, ma'am.
कौन सा है बेटा
3.7.
this one okay that means 20 25 26 27 so 27 into 0.001 that is 0.027 plus how many divisions have gone away on the main scale 2.35 exactly 2.35 plus this one. So you have the diameter, you have the A value. Okay, again the experiment will be repeated for the next. So how to go for that? Let's do that. Let me minimize it little. Zoom out. Wait. So now when you go with this cursor, you can keep cursor here, this arrow, and then this is the third boundary and this is the fourth boundary. Okay, so when you keep crosswire at the boundary of fourth dark ring, again you can see the change in the readings on the vernier scale as well as the main scale. So on main scale actually is still 2.35. Okay, and on vernier you can see the readings how like this. Okay, so you can see the division which is going to match finally, and then try to find out actually the A value. Okay, so when we go through this A values on sliding this micrometer towards left as well as right by turning them as clockwise or anti-clockwise direction, so you can see the result of A and B, which is the sum of main scale and the vernier scale, division on vernier scale into least count. ठीक है. So we will have this value and then basically we will go with the we'll start to rotate on the different side. Okay. So now if you rotate this, it will come towards right. Now again this is at center. This is the boundary of first and the boundary of second dark. Then you can see the change in the B value. So now 2.5 completely gone away, 2.55, and then you can see the exact number of division which is coinciding on the vernier scale into least count, and then put it in the formula and find out the diameter. Like take a difference between A and B, find out D, take a square of it, right? And then you can see basically the difference between the diameter, difference in diameter square in case of liquid as well as in case of air film, and then take a ratio between them और find out क्या find out करेंगे आप यहाँ पर this experiments. So this is my humble request to all of you when you go through the experiment, as observation table is not mentioned here, but what you can do, you can use this one. So it is not in the included in the simulator as well. We have done in case of variation of magnetic field or last previous day's experiment. Okay, so but anyways, let's do this. You can see here the observation table, write all the values here, a value and b value, take a difference between them, find out d square, and this is a difference in diameter square in case of liquid. Fine. So here when you pour some drop of liquid, so you have this value, and then take a ratio of them. Once you have the ratio, basically you can find out the refractive index of the given liquid. Okay, so now you have idea when we introduce some amount of liquid into the wedge-shaped thin within the space of plane of convex lens and plane glass plate, so diameter get reduced. Okay, so this was overall about the Newton's ring experiment, through which actually we can do to have major applications refractive index of any liquid. Now you can see this is the beauty of this simulator virtual lab. Here you can change time to time the, like suppose here when we put the medium, now if we use rather than water acetone, so basically you can see now source of light also, suppose now it is green light and the light on, so you can see here the green, instead of getting yellow circles of bright light, now we are having green. Okay, so here you can see the difference. Fine, and the radius of lens suppose 60 centimeter, then what will happen again, you need to focus this as well. Now it is becoming fainter, so let's make it bright, more clear. I think it's more clear. Then you can see the readings here. Okay, just by placing the crossfire at the boundaries of bright and dark. Bright and dark. This is the boundary of first arc. This is the boundary of second arc, and then see the results here. Okay, and then you can compare for different light source. This is the beauty of experiment. Like we can have feel of different medium, as well as जैसे कि गांव में सभी जगह केरोसिन इजीली मिल जाता है. So we can use this. Now suppose if we use a red light on, then again you can see this, make it more focused. You can click on it until it becomes bright, more clear. Again, you can use the cursor here so that you can keep change the order of ring. count them and try to find out A and B, take difference between them so that you can have D, take D square, and then you can do the entire experiment. So this was actually Newton's ring refractive index. So basically you can see the result also in every experiment. Fine, suppose we use this, and then if we keep kerosene here, then show the result. The wavelength is for red light it is 6700, and manually you can find out the mu value. Okay, so this is about actually Newton's ring. Similarly, we can see the next experiment. Wait a minute, let me go back so that you can have idea. ओके एक्चुअली हमारे सराउंडिंग में सर एक क्लास चल रही है. संजीव सर, क्या बहुत ज़्यादा डिस्टरबेंस हो रहा है? हाँ, वो एक्चुअली रेगुलर क्लास चल रही है, तो आज उनकी लैब नहीं है ना? सो बैकग्राउंड में एक्चुअली मेरा ऑफिस का लोकेशन ऐसा है कि एट दिस वॉल यू कैन सी on the back of this wall the class is going on. कि बहुत ज़्यादा डिस्टरबेंस हो रहा है. Okay. Okay, now we can see the next experiment, diffraction grating. How to go with this experiment? Let us see. This is from, you may check it from the laser optics, and you can see this. Wait a minute. Optics virtual lab. So when you go through the optics virtual lab, there are so many experiment resolving power of prism, angle of prism using spectrometer, IA curve, ID curve, determination of Cauchy's constant, refractive index of a material of a prism, dispersive power of a prism, diffraction grating. Just click on it because it is already included in virtual lab curriculum, which is prescribed by NEP, New Education Policy 20. So please follow it. So again, we can see the diffraction. What is diffraction? Everybody knows that the phenomena of bending of light around the corner. Suppose we have this hand. Okay, so when we go to the dark room at night, when you switch off the light of the room, you keep palm like this and keep falling the torchlight or mobile light onto it. You can see the image of your palm at the surface of the wall. Okay, so basically, you can see these are nothing but obstacle. So around the corner, the light will bend. So this phenomenon of bending of light is known as actually diffraction. But when you have a particular size of the aperture, so basically aperture through which actually light bends, so basically, you can see the diffraction pattern exactly in the form of alternate arrangement of bright and dark bands. But as you know, there are two type of diffraction patterns like prescribed by the Fraunhofer and Fresnel. The Fraunhofer actually in our lab we generally perform the Fraunhofer type of diffraction pattern. In basic course, Fresnel is also included. But some days, Shivani, Shivani, yeah, thank you so much, Shivani. Okay, so here you can see that normally in our lab we perform Fraunhofer diffraction pattern very easily. Okay, so with a single slit, with a double slit, with N slit. So in our lab actually single slit and diffraction gratings are available. But in BTech course actually diffraction grating is only possible. No, single slit is not included in syllabus. Okay. So, but anyways, it is included in BSc. So you generally perform with a single slit. Okay. But this is diffraction grating. Grading is the basically method through which actually we can find out the wavelength chromatic source having more than one color, like white light, mercury light. So when you use mercury light consisting of seven colors, out of these seven colors only few colors can be observed by the human eye. जैसा रेनबो होता है ना, तो सेवन कलर्स ही होते हैं, बट आप उन्हें देखकर पहचानते किसको हो? आप कहते हो ये तो ब्लू है, आप कहते हैं ये रेड है, आप कहते हैं ये ग्रीन है ना? बाकी कलर्स हमें क्यों नहीं दिखते एग्जैक्टली, लाइक ब्लू, इंडिगो, ये हमें क्यों नहीं दिखते? वायलेट दिखता है। एक्चुअली ब्लू और इंडिगो के वेवलेंथ इतने करीब हैं, दे इंटरफेयर सो मच, like we cannot identify the clear the colors in a very easy way. So normally वो clash करते हैं, so basically हम वो नहीं बता सकते कि ये इंडिगो होगा कि ब्लू होगा. In the same case for orange and yellow also. So we generally perform in our lab. तो कौन से out of seven में से कितने दिखते हैं हमें? हमें दिखते हैं violet and then green and then red. Can you please tell me whose wavelength is large and longer and shorter from violet to red? Can anyone please tell me whose wavelength is longer or shorter in Vibgyo?
Red has the longest wavelength and violet has the smallest wavelength.
Wavelength is yeah, wavelength is shorter. किसके लिए? For red color, and red color it is
Greater.
longer. Fine. But the wavelength is longer, then what will be about the frequency? Large. So energy would be large. अगर वेवलेंथ शॉर्टर होगा तो इनवर्स रिलेशन हुआ ना फ्रीक्वेंसी का एंड एनर्जी का. फाइन, ठीक है. You can see the relation between frequency, wavelength, energy. Now come back to the experiment. So here actually we have again the aim theory, aim operators use theory, and then go with the teaser and then observation table in the simulator, and then go with the assignments in the form of self-evaluation, pre-test assignments as a test. Okay, so you can perform. Now you can go through the theory and go with the self-evaluation, and then post-test assignment. You can see several numerals, calculate the number of lines per unit length, the given grading using the simulator. Simulator के लिए आप a number of lines calculate करिए, capital N, using green light. So you can do some more applications here. Find the diffraction angle of the red line for the order, that is a small n in equal to 1. So what is the formula for lambda? You can see here. Here there are two aims. Number one, to determine the number of lines per millimeter of the grating using the green line of mercury spectrum. Okay. Then what is the second? To calculate the wavelength of the prominent lines of mercury by normal incidence method, the wavelength of a spectral line. So for a fixed value of wavelength, let us do that number of lines निकालना है, capital N निकालना है, and then ये, ठीक है. So you can see basically the single slit. First of all, this is the single slit. So light is coming from the source of, and then it comes to the convex lens. Source of light is kept at the focus of the convex lens, so the emergent light will come to plane and parallel, become to plane and parallel. This parallel plane and parallel wavefront will fall normally on a slit, on the surface of the slit. This is a slit and it falls normally on the, okay? So around the corner, suppose this is the aperture of the obstacle slit, which is A. So around the corner light will bend. So entire diffraction pattern will be focused at some other point. So now you can see the center is bright in case of Fraunhofer. The center may be bright or dark in case of maybe bright and dark in case of Fresnel type. But here we are using Fraunhofer, in which either source of light or a screen are placed at infinite distance. So to converge light, to focus light on the screen, basically we are required to have lenses. At least two lenses are required. One lens is associated with the source of light, so this will basically come to here. Wait a minute, just wait. I'm really very sorry. Just because of some office work, I'm just taking signature there. Okay, so come back to the workshop. So you can see the diffraction pattern here, and this is a logic, and you can see entire theory. Just because of less time, I'm discussing a little bit here. You can see spectrometer is basically consisting of three parts. One is collimator, another is prism table, third one is telescope, through which actually generally we keep view the diffraction pattern. Okay, so this is a grating, so you can see entire view here, different colors. Okay, just because we are using white light source here, here in this is the source of light. Now come to the procedure. Procedure you can go with the simulator like the user can use a grating spectrometer to measure the wavelength of blue, green, violet, red. Okay? Here you can see some yellow light also, but in our lab generally we observe violet, then green, and then red. Okay. So here the components are spectrometer, grating, mercury vapor lamp, and what are the variables in the reel? You can see the telescope calibrate slider. So go through with the telescope. First of all, what we will do, we will focus. We will focus the telescope. You can see the better view of leaf. Right now we can start. Okay. So these are some keys like switch on the light. You can see the light. Fine. The light is coming from here. This source slit is there, and then this is the spectrometer. Center part. This is prism table on which we can mount basically prism as well as we can mount diffraction grating, and this is the part of telescope through which actually we can measure out the vernier scale V1 and V2 reading at different colors. Okay, so fine, we can keep this as this, and then just take the width of the slit also. Okay, and then place the grating. So you can see this grating, and telescope is set at 90. So the view is a center. You can see you have to keep this. These are the bands. There you can see actually colors. Fine. This is a yellow, and then okay. So this is at 90 degree. Suppose if we go with the 45 degree telescope, at at 45.8. You can see the curve here. Fine. Or by rotating plus 180, make a here. This is a V1 scale and V2 scale, as you know. The least count is 1 by 60 minute, and we have to see like this is 30, 225, and this is 224. That it means 224 have gone away, and then you need to find out which division is coinciding exactly there. Okay, so wait a minute, let me enlarge it. Fine. So here you can find out the exact coinciding division. Fine. One is coinciding. This is the vernier scale, this main scale. Okay. Once you decide this is V2 and this is vernier scale V1, so basically do not keep change it. Okay. So we can see on main scale this is 230, this is 25, and this is 224. So exactly at 224, 224 is the main scale reading, and on vernier you can see the division which is coinciding from 0 to 30. Which division is coinciding exactly from 0 to 10? I think so. Some number of division is quite. Can you see that? One is coinciding exactly from 0 to 10. This is 1, 2. I think it is 2. Maybe. What do you see? Second वाला शायद मैच कर रहे हैं. So 2 into 1 by 60, and main scale reading is 224. 224 plus 2 into 1 by 60. So you can convert this 1 minute into degrees, 0.016667, like you may choose it 0.0167. Fine. So this is equivalent to 1 minute. So 1 by 60 minute is equal to, you can convert it and find out the value in degrees, or you can use your calculator. Fine. There is automatic conversion, so you may convert the theta in degrees or radian. Okay, a minute in seconds also. Fine. So here you can see basically the number of orders, or by just you can change the number of orders, different colors there. So for first order n equal to 1, and for second order it is n equal to 2. At the same moment, suppose you are observing this, so you can see the reading here also. At this moment, this is V1 scale, you can see this is 50, and this is 45, 46, 47, 48, 49. So what is it? 45. This is 44. So main scale reading is 44, and vernier scale is what, which division is coinciding exactly? Just try to think on. So 0 to 10, no. 10 to 20, no. 20 to 30, say, I say it is 20 to 30, we can say some this division, 21, 22, 23, 24, maybe. So 24 into 1 by 60, and 44 is the main scale reading. So 44 plus 24 into 1 by 60 gives some value in decimals, 24 point something. So you can go up to the two decimal values. Fine. And then this is V1 and V2. Okay. So on right hand side, similarly, you can slide this to here also. Okay. So you can see the color. Just wait a minute. So you can slide it and see the colors again. Okay. So again, this is the reading B. When you keep slide this around 180. So when we do this 180, then you can have the readings of V1 and V2. So we have actually completed two experiments here and then try to find out the value in the observation table. Observation table is as usual not available here in this experiment. So, but you can make it in this way for the different colors left and right V1 and V2 on left hand side as well as right hand side. Then this is 2 theta a minus b and keep change a minus b here and then take a mean of it by theta and what is the value of total number of lines drawn on the surface of grating per centimeter per millimeter or per inch. So here I think in millimeters, so you can convert it into millimeters and try to find out the number. Fine. Once you have this value of n, then you may use the value of n here, and then you can find out actually lambda value. Okay. So this is the beauty of this experiment. Wait a minute. Let me. Important call. That's why I lose myself. So this was overall about this experiment. You can perform so well, and I'm wishing you all the best. Like you perform the experiments. Now you may ask some questions. If you have any questions, please kindly ask me the questions. Okay. So, but all the questions are become more important. Go with the theory and from the books, textbooks, as well as reference books. So please follow the textbook and reference books properly. Then you can have idea. Otherwise, you will pass the BSc program and then MSc program, but cannot realize the effect of interference of light or diffraction. But please try to watch in everyday life how the diffraction takes place or interference going on. Is it happened in the daily life or not? Try to find out these answers. So when you realize, basically you can have idea of the physical concepts because already you are using in your daily life whether you can have the good interference or bad interference or good diffraction pattern or bad diffraction pattern. So it doesn't matter, but try to realize in the daily life how the light bends and go on and making a geometrical shadow, everything, because you must have this answer when you know all those formula and theory. You can have appropriate answer and then try to follow the experiments when you go initially your physical lab first go through the um, virtual labs, then you can have idea like what power should be switch on as a is a high voltage or is a low voltage, what will be the result, because once you realize this In virtual lab, you can have a full idea like now we need to switch on this circuit or this one, or how to play with the values. Okay, so this will help you a lot. There will be no need to have any support of technician or any faculty member, because this is a self-learning program. So always begin on self-learning also, because when you go through the process of self-learning, then you will on your neural networking, like you will make a network and with the neurons, like this could happen or this will not happen, so you can have a satisfaction factor also. And there are so many powers, like you can make them. Okay, so this is the beauty of the physical concepts virtual lab, through which you make realize like this is important for you when you go to the lab. Of course, no one can take away the physical labs always matters, yes, but virtual lab always help us to perform the experiment in the physical lab. Okay, so basically, a good learning could be gained with the help of virtual lab that we are realizing. Okay, any questions?
Thank you, madam. This is questionnaire. Any student can resolve their queries regarding two experiments organized today. स्टूडेंट्स, आप अपने क्वेरी को रिजॉल्व कर सकते हैं. किसी का कोई क्वेश्चन हो तो पूछ सकते हैं. I mean, there is no question on this last day. This is final day. So now we will move. As we are very well known about this, this workshop is organized by Government Degree College Badaयूं under the affiliation with MJP University Bareilly and in collaboration with the PSIT Kanpur under the auspices of IIT Roorkee. Uh, this is the workshop organized during 6 to 11 January 2024 by Department of Physics, Government Degree College Badaयूं. There are several registrations have been done for this workshop from several states of the country. There are 665 registrations are made for 3 mini workshops for semester 1, semester 3 and semester 5. So I would like to request you to cooperate us for this validity session. Please be stay during this validity session. Our chief guest of this workshop is Dr. Binay Tripathi, Project Associate, IIT Kanpur, and a special guest, Dr. Sumant Tripathi. She is also the Project Associate from IIT Kanpur. Our special guest are Professor Bandita Srivastav, KLDAV College, Roorkee, and Professor Dr. Divangar Sapate from Government PG College, Thane, Maharashtra. So I would like to request my principal, Dr. Shraddha Gupta, to welcome all the guests and the participants participating in this workshop from several states of the country. Madam, please welcome all the audiences. Thank you.
Go.
जी मैडम, यू आर ऑडिबल। प्लीज वीडियो ऑन कर लें मैडम। I mean bandwidth is very low because this issue, madam is not audible.
Okay.
Now,
Am I audible?
yes, you are audible, madam.
Okay. Thank you. Thank you.
Yes, ma'am.
सबसे पहले मैं सबका वेलकम करना चाहूंगी इस वर्कशॉप में, जिसमें अलग अलग पूरे देश से लोग जुड़े हुए हैं। मैं लगातार फीडबैक्स देख रही हूँ, उसमें अलग अलग स्टेट से, महाराष्ट्र से और हिमाचल प्रदेश से सब लोग जुड़े हुए हैं। और मैं आशा करती हूँ कि ये 6 दिन की वर्कशॉप में सबने वर्चुअल वर्कशॉप में स्टूडेंट्स ने और साथ के साथ जितने फैकल्टी मेंबर्स और जुड़े हुए हैं, उन्होंने भी अपना एक वर्चुअली अपना एक नॉलेज को गेन किया होगा। और मैं सबको शुभकामनाएं देती हूँ और इस सेशन के लिए और स्पेशली राठौर सर के लिए धन्यवाद देती हूँ कि उन्होंने इतने कम समय में इस पूरे को ऑर्गेनाइज कराया और सफल संचालन के लिए मैं उनको धन्यवाद देती हूँ और सभी बच्चों को शुभकामनाएं देती हूँ कि इस वर्चुअल वर्कशॉप से हमने जो सीखा है उसे प्रैक्टिकल लाइफ में या फिजिकली लैब में भी इसको एक्सपेरिमेंट को करके देखें और इसकी जो थ्योरी है, थ्योरी बैकग्राउंड, इसको भी जरूर पढ़ें। उससे तभी वर्कशॉप को करने का हमारा जो एम है वो जो है ना सार्थक होगा। इसलिए मैं सर को दोबारा धन्यवाद देती हूँ और सर से कहती हूँ कि सर इस प्रोग्राम को आगे करें। धन्यवाद।
थैंक यू मैडम। सभी पार्टिसिपेंट्स, सभी फैकल्टी मेंबर्स का स्वागत है।
थैंक यू मैडम, श्रद्धा मैडम।
सभी का स्वागत है। मुझे लगता है डॉक्टर अपर्णा दीक्षित मैडम को कोई लेक्चर लेना होगा, इसलिए वो वीडियो ऑफ किए हुए हैं। कोई बात नहीं।
नहीं सर, बात नहीं है। मैं एक्चुअली कुछ ऑफिस काम थे जिनको थोड़ा
Okay,
देखने
madam.
लगी थी।
Please
कोई बात
keep
नहीं।
your
मैम
video
सॉरी,
on.
मैं आपका नाम स्पेशली ले नहीं पाई।
I would like to request all the
मैम
participants.
सॉरी, मैं आपका
Please.
नाम लेना भूल गई। और अपर्णा मैम का मैं एक बार फिर से धन्यवाद देना चाहूंगी कि उन्होंने
नहीं मैम,
जिस
कोई बात
मेहनत
नहीं।
से, जिस
थैंक यू सो मच
डेडिकेशन
मैम।
से
जी,
सॉरी मैम, ये स्पेशली मैं, क्योंकि
इट्स ओके
आपका
मैम, कोई
थैंक
बात
यू तो
नहीं।
शब्दों में कहा भी नहीं जा सकता मैम जी, क्योंकि आपका
नहीं,
जो
आप
साथ है
लोगों
मैम
ने
वो थैंक यू से भी ऊपर है
जी,
मैम। जी जी
Now
नहीं
I
नहीं, बिल्कुल हम लोग तो जुड़े ही हैं। हम लोग चाहते हैं कि जितना ज्यादा से ज्यादा हम IIT कानपुर के साथ मिल करके बहुत सारी वर्कशॉप्स करते रहें, बच्चों को जितना बेनिफिट मिले। और आजकल जो वर्चुअल रियलिटी कॉन्सेप्ट पे
मैम।
जो बना रहे हैं, उस पर भी सबको कुछ मिलता रहे। अब नेक्स्ट एक वर्कशॉप हम
जी
लोग करने जा रहे हैं, इसमें से कुछ हमें स्टूडेंट्स आपके तरफ से भी चाहिए होंगे, सो दैट उसे ज्वाइन करें वर्चुअल रियलिटी में। और ये 5 डे की वर्कशॉप होगी और 5 डे
जी
की
जी
वर्कशॉप हम ऑनलाइन रखेंगे, बिकॉज ऑफलाइन में सब लोग जुड़ नहीं सकते हैं, लिमिटेशंस होते हैं। तो ऑनलाइन रखने में क्या है कि एक तो हैंड्स ऑन अच्छा सा हो जाता है और दूसरा बच्चों को एक कंफर्ट जोन भी मिल जाती है, आराम से सीख। तो हम कोई
यस
कंपल्शन
श्योर
ऑफलाइन वाला नहीं रखते। जी बिल्कुल,
तो
यस
ठीक है।
हम
श्योर
हमारे गेस्ट जो गवर्नमेंट पीजी कॉलेज थाने महाराष्ट्र से हमारे बीच
थैंक
वर्कशॉप में लगातार बने रहे हैं, सीनियर प्रोफेसर हैं डॉक्टर दिवंगर सपाटे सर। आई वुड लाइक टू रिक्वेस्ट डॉक्टर दिवंगर सपाटे, प्लीज address us and share your experience of this workshop if he is available. Professor Divangar Sapate, no network, अभी तो वो थे। Now I would like
सर
to
अभी अवेलेबल नहीं है।
जी now I would like to request Dr. Bandita Srivastava madam from KLDAB College, रुड़की।
सर ये नेक्स्ट सेशन कब होगा वर्चुअल लैब में? अब कोई होगा कि ये लास्ट है?
नेक्स्ट आपको बताएंगे, एवी सेमेस्टर्स के लिए कराएंगे।
ओके सर।
प्रोफेसर वनिता श्रीवास्तव भी अभी डिस्कनेक्ट हो गए हैं और मैं रिक्वेस्ट करूंगा सीधे सीधे डॉक्टर सुमन त्रिपाठी मैडम से, जो आईआईटी कानपुर से हैं। आपका मार्गदर्शन लगातार मिलता भी रहा है बीच बीच में, क्योंकि गवर्नमेंट इंजीनियरिंग कॉलेज बांदा कॉलेज एफडी भी चल रहा है, इसलिए आपकी व्यवस्था बराबर वहाँ बनी हुई है। और आज भी आपने समय दे दिया है। डॉक्टर सुमन त्रिपाठी मैडम से मैं अनुरोध करता हूँ कि वो प्रतिभागियों का मार्गदर्शन करें।
थैंक यू सो मच सर, आपका बहुत बहुत आभार कि आपने हमारे वर्चुअल लाइफ की जो मोटिवेशन को बढ़ाया रखा है और बरकरार रखा है बच्चों के बीच में। सर मैं वीडियो ऑफ करना चाहूंगी बिकॉज ऑफ यहाँ नेटवर्क का बहुत इशू है।
नो इशू, नो
मैं
इशू
जहाँ
मैडम, नो
बैठी
इशू,
हूँ,
नो
ओके,
इशू।
मैं वीडियो ऑफ करके बोलूंगी सर, ठीक है?
ओके ओके।
ओके। So as we come to the end of this wonderful 5-day program of Government College Badaयूं, so I would like to firstly thanks to organizer Dr. Shraddha Gupta, principal and patron of the Government College Badaयूं. I think so, madam. Without your efforts and without your interest, it not be possible to organize such kind of the 5 days workshop. So I really appreciate ma'am your efforts. So I will like also be can you please continue your efforts towards the virtual lab activities. So students can more learn more and more things. तो आप अपने इस एफर्ट्स को, अपनी इस मेहनत को मैम बरकरार रखिए। वर्चुअल लैब की जो मदद से आप बच्चों के बीच में जितने भी हैं एक्सपीरियंस, इसमें नॉलेज को एनहांस कराते रहिए। एंड सो आई वुड लाइक टू ऑल्सो अप्रिशिएट डॉक्टर संजीव राठौर दैट help to make it happen. So without your effort, sir, I think so this is not also possible to organize such kind of the workshop. So Dr. Sanjay Rathod, I really appreciate your work. So and IIT Kanpur, sir, really appreciate. मैं अपनी व्यस्तता के कारण इन 5 दिनों में आपसे जुड़ नहीं पाई। मैंने आपको बताया अभी हम आईआईटी बांदा में हैं सर, और यहाँ 5 दिन हमने वर्चुअल रियलिटी की वर्कशॉप करा रहे हैं सर। बच्चों को हमने जो गैजेट दिखाया, न्यू टेक्नोलॉजी दिखाई, उनको रियल कराया कि वर्चुअल रियलिटी वर्ल्ड है क्या, हम कहाँ हैं। बहुत इंजॉय किया और बहुत कुछ सीखा है। तो I appreciate and thank the valuable speakers who share their valuable knowledge that make all the students learn together. So speakers that help the participants to expand their knowledge. So Praparna Dixit from PSIT Kanpur, मैडम आप तो बहुत ही अच्छा कर रही हैं, तो आपके बारे में जितने शब्द कम है उतने ही बोला जाए। आपके वर्क को मैं बहुत ज्यादा अप्रिशिएट करूँगी मैडम। College Roorkee, Department of Physics, and Professor of Physics Department from Government PG College, Thane, Maharashtra. So this success of the workshop is just a essence of our collective commitment to learning and the collaboration with the IIT Kanpur Virtual Lab. So, and I also want to lastly thank to each and every participant for your active participating during the all workshop. So students, please keep learning, please enhance your knowledge. देखिए जैसा मैम ने बताया था अभी अपना मैम ने, वर्चुअल लैब इज नॉट गोइंग टू रिप्लेस द फिजिकल लैब, but with the help of the virtual lab we are going to enhance your technical knowledge. So keep learning such kind of the from this kind of the virtual platform and virtual lab. So thank you so much sir to organize such kind of the virtual so much. यही मैं अपना स्पीच थोड़ा ओवर करूंगी क्योंकि सर नेक्स्ट मेरा सेशन है यहाँ पे, तो बहुत ज्यादा मैं बोल नहीं पाऊंगी।
No issue, no issue. Thank you very much for your benefited talk among the students and participants, the faculty members from several states from the country. Now, I would like to request our chief guest, Dr. Vinay Tripathi, sir. He is also the associate from IIT Kanpur. एक्चुअली उनका भी मार्गदर्शन हमें बराबर मिलता रहता है, और उनके बगैर मार्गदर्शन के इतना शॉर्ट टाइम में हम लोग ये कार्यक्रम करा पाना बड़ा मुश्किल हो रहा था। और सर ने बड़ी जल्दी से अपना एनओसी दिया, जिन रिसोर्सेज को हमने अपने वहाँ पर उनको शो ऑफ किया कि सर हम ऐसा नहीं कर पा रहे हैं। सर ने कहा जैसे आप चाहें अपनी वर्कशॉप ऑर्गेनाइज कराइए, दैट इज वेरी गुड। ये कोऑपरेशन आईआईटी कानपुर की तरफ से हमें मिल रहा है और मिलता रहेगा। मैं विनय सर को
जी
आमंत्रित
सर,
करना
आपको
चाहता हूँ।
जब भी ऐसे वर्कशॉप हो सर, हमारी तरफ से आपको पूरा फ्री हैंड है। आप जो चाहे हमारी हेल्प से, यानी आईआईटी कानपुर वर्चुअल लैब की मदद से आप जो चाहे हम आपको पूरा फुल सपोर्ट करेंगे सर
जी
इसमें।
जी जी
सर
बिल्कुल।
मैं चाहूंगी एज ए कीप लर्निंग जो आप इनको सिखा रहे हैं वर्चुअल लैब से सर,
जी
वो आप काम एक्चुअली जो हमारा मिनिस्ट्री ऑफ एजुकेशन का मोटिवेशन है, आप अपर्णा मैम हुई, मैं आशुतोष सर की बात करूंगी, आयुषी मैम हो, मेरे ये जर्म्स हैं सर, मेरे ये
जी
गिरे जो कहते हैं।
जी
एक्चुअली कल ही मैंने यहाँ बच्चों को कहा था कि यही 3 लोग हैं जो वर्चुअल लैब की जो प्रकाशता को बनाए रख रहे हैं।
जी
एंड आईआईटी कानपुर सर आपके आप लोगों तीनों के काम को बहुत अप्रिशिएट कर रहा है,
जी
स्पेशली हमारी टीम।
जी
और मैं अपने ये सारी जो काम है एक दिन जरूर जब मौका मिलेगा बुलाने सर को बिठा के हम आपकी काम से प्रशंसा करेंगे कि एक्चुअल में कौन कौन हमारे लिए बहुत ज्यादा काम कर रहा है, एक्टिव
जी
कर रहा है।
जी
तो
जी
उसमें आपकी भी कॉलेज है सर, थैंक यू सो मच सर। और
जी
सर मैं
जी
चाहूंगी कि आप बच्चों को थोड़ा एडवांस तरफ भी वर्कशॉप में लेकर आइए, जैसे
जी
VR AR, जैसे आज हम गवर्नमेंट कॉलेज बदायूं में हैंड्स ऑन ट्रेनिंग दे रहे हैं AR
जी
पे, VR पे, वर्चुअल में, क्योंकि ये सारे फ्यूचर है हमारे बच्चों का,
जी
आने वाली टेक्नोलॉजी फ्यूचर है।
यस सर।
जैसे अपन हम अपने बच्चों से
सुमन
चाहते
मैम,
हैं सर, आप मैं
इधर
चाहती हूँ
मैं थोड़ा सा,
एडवांस
हाँ
टेक्नोलॉजी में सर आप इनको जोड़िए अपने बच्चों को सर,
हाँ, सुमन मैम, मैं
लर्निंग के
थोड़ा
साथ साथ
ये
आप
कहना
इनको।
चाह रही थी, अभी फ्यूचर में अभी मैं एक वर्कशॉप 5 डेज की करने जा रही हूँ, जिसमें कि
जी
जो
मैम।
रियलिटी लैब हम लोगों ने अभी तक जितने एक्सपेरिमेंट प्रिपेयर किए हैं 4 to 5, तो वो हम
जी
स्टूडेंट
जी
को
मैम।
एक्चुअली पूरा उनको उसका पूरा वर्किंग पूरा मॉड्यूल दिखाए हम वहां पे, और उनका
जी
हैंड्स
जी
ऑन
जी बिल्कुल।
कि एक्चुअल में कैसे ऑब्जेक्ट क्रिएट किए जाते हैं यूजिंग ब्लेंडर, कैसे आप सब चीजों करते हैं, वो सारी चीजें उनको थोड़ा सा 5 डेज में जस्ट विद इन एन आवर उनको करके देंगे, और वो उनको कुछ
बिल्कुल
असाइनमेंट्स भी देंगे, सो दैट उसे वो सीखे भी
जी
और
बिल्कुल।
कुछ अपडेट करें। तो इससे कुछ स्टूडेंट्स निकल के आएंगे सर के बधाई से,
बिल्कुल मैम। हाँ।
जो भी आसपास है वो भी निकल कर आएंगे, है ना, सो दैट वो आईआईटी कानपुर से जुड़े, उनका भी
जी
इंटर्नशिप हो सके, है ना, ऑफलाइन या ऑनलाइन, जब भी वो फ्री हो कुछ इस तरीके से काम हो सकता है ना।
जी
और
थैंक यू
ये है, और बाकी जो इधर कुछ लैब हमने देखी उनमें जैसे कहीं कहीं पे लगता है कि हाँ कुछ फीचर हम इसमें और इनोवेशन थोड़ा कर सकते हैं फॉर अ बेटर अंडरस्टैंडिंग, तो वो भी
जी जी
जी
है अभी,
जी थैंक
तो
यू मैडम।
नहीं
So
है तो
without
उनको
any
भी
delay, I would like to request Vinay Tripathi to address us. As we have organized this workshop directly on Google Meet and live on the YouTube channel, है ना, Vinay sir? Sir, you are not audible.
Hello.
जी sir, you are
Hello.
audible. You are
Thank you,
audible.
Sanjeev sir.
Audible.
Thank you. Thank you. Good afternoon, sir.
जी sir.
And respected principals of the Government Degree College, Badaयूं, and Dr. Shraddha Gupta, and convener of this workshop, Dr. Sanjeev Rathore, sir. Uh, and dear students and respected all speakers of this workshop, firstly we congratulate to organize a workshop to this workshop and conducting a workshop, wonderful and knowledgeable full 1 week workshop, national workshop on a physics experiment of by virtual labs organized by Government Degree College, Badaयूं. I hope it will be a highly valuable uh, of this workshop for Department of Physics of BSc program students. And I have seen different things covered at a different topics by a different renowned speakers such that Dr. Aparna Dikshit ma'am, PFIT Kanpur, Dr. Vandita Srivastav ma'am, KLADV College, Roorkee, and Dr. Digambar Sapte sir, Government PG College, Thane, and other renowned professors are taken a lecture on different and covered a different topics of the physics subject of BSc students. So this types of a program it will be very valuable for the students. I hope these types of a program will be carried from your sides, and I will always support to you. और इस तरीके के प्रोग्राम स्टूडेंट्स के लिए बहुत ही यूजफुल होते हैं। इसमें मैंने देखा कि स्पीकर्स अपर्णा मैम का बहुत contribution, उन्होंने हर लेक्चर को कितना क्लियर एक्सप्लेन किया और लिया, बच्चों को बताया, समझाया। इस तरीके के प्रोग्राम होते रहें, हम लोगों का यही उम्मीद रहती है और यही सपोर्ट रहता है। और इसके लिए बदायूं में संजीव सर आप हमेशा एफर्ट करते रहते हैं, श्रद्धा मैम का सपोर्ट रहता है, तो हम लोगों का सपोर्ट हमेशा बना रहेगा। और ये अवेलेबल और नॉलेजेबल फुल वर्कशॉप ऐसे ही कंडक्ट करते रहें, हम लोग हमेशा आपके साथ रहेंगे और इस चीज़ों को आप कैरी करते रहें। एंड थैंक यू फॉर दिस एंड ऑल द बेस्ट फॉर योर फ्यूचर।
थैंक यू सर, थैंक यू सर, थैंक्स अ लॉट। राजकीय महाविद्यालय बदायूं और पीएसआईटी कानपुर के लिए आपका जो सानिध्य बना हुआ है बहुत ही वैल्यूएबल है सर, और जिसके बेस पर हम देश के विभिन्न राज्यों के स्टूडेंट्स को इतना बेनिफिट दे पा रहे हैं। वर्चुअल लैब का जो सिलेबस है वो नेशनल एजुकेशन पॉलिसी 2020 के पर्सपेक्टिव में बहुत इम्पोर्टेंट और चैलेंजेबल भी है, तो इसलिए इन वर्कशॉप को आईआईटी कानपुर के थ्रू हम लोग कंडक्ट करा पा रहे हैं। ये सारे स्टूडेंट्स अच्छी तरीके से जानते हैं और उसका बेनिफिट भी ले रहे हैं। तो मैं सभी का धन्यवाद ज्ञापन करना चाहता हूँ। सारे पार्टिसिपेंट्स जो डिफरेंट जगह से हमारे इस राजकीय महाविद्यालय जो उत्तर प्रदेश के एक पिछड़े जिले से है, बदायूं से, तो और उन सभी प्रतिभागी शिक्षकों को जिन्होंने हमारे साथ रहकर हमारा मनोबल बढ़ाया और राजकीय महाविद्यालय के द्वारा आयोजित इस 6 दिवसीय ऑनलाइन वर्चुअल लैब जो भौतिक विज्ञान के विद्यार्थियों के लिए आयोजित कराएगी, उसमें तीनों सेशन में आपकी प्रतिभागिता, आपका सहयोग बना रहा, इसके लिए हम ऋणी रहेंगे। और ये वर्कशॉप बड़े ही शार्प तरीके से आयोजित कराई गई यूट्यूब चैनल पर, इसके लिए राजकीय महाविद्यालय बदायूं के भौतिक विज्ञान विभाग भौतिक विज्ञान परिषद के अध्यक्ष अली रजा, थैंक यू फॉर ऑल। मैं महाविद्यालय की प्राचार्य से अनुरोध को शट डाउन करने के लिए अनुमति प्रदान, धन्यवाद।